So the first of our presentations will be given by Bill Line. Bill, we've had collaborations with Bill for many years. He was the original GOES-R liaison for the Storm Prediction Center, and he's now a forecaster with the National Weather Service office in Pueblo, Colorado. And Bill is going to share about heavy precipitation and flash flooding in mountainous terrain. Bill.
All right, good morning, everyone. It's really awesome to see so many familiar faces and a lot of new faces as well. So I'm excited to connect or reconnect with many of you this week. And I'm also very excited to share with you a forecast challenge that's really relevant to us in southern Colorado, but also a lot of folks in mountainous terrain offices. And that's heavy precipitation and flash flooding, specifically impacting burn scars. So this first block, it's going to be PowerPoint. I'm going to introduce burn scars, talk about burn scars and how it's a challenge for us in forecast offices. And then the rest of the blocks will be looking at a few cases in AWIPS. And please, as was mentioned along the way, if you ever have any ideas for tools or products, etc., that you think might be helpful in these types of situations, I certainly want to hear about it. I know everyone else wants to hear about it. So yeah, definitely keep it informal and share not just me to you, but I want to hear from you all as well. So this is not a volcano, this is a fire. This was the spring fire from this last year. And this is a significant fire, a lot of burn area, and one of the fires I'll talk about in this block. And again, in this block, I'll talk about burn scars as well as a new or tool that's under development by the JPSS program that shows potential to be very valuable to us folks in offices with burn scars. So in Pueblo, Colorado, our forecast office, if you're not familiar with Pueblo, it's just south of Colorado Springs along the Front Range, which is south of Denver. We forecast for all of southeast and south central Colorado, so just a wide variety of weather. It's extremely challenging. We like to say the weather starts in Colorado and then moves east. Of course, we have the southeast plains where we'll get severe convection, tornadoes, flash flooding out there, hail, wind, etc. But the nice part is by 9 o'clock p.m., the storms are already east in Kansas and we're done. So pretty perfect there. And then, of course, we have the mountains, very challenging to forecast. You have winter weather out there. We're forecasting fire weather across our forecast area. And of course, one of our main forecast challenges are the burn scars. So we get a fire, it burns a lot of area, creates a burn scar, and you could see these areas highlighted are all of the burn scars in our forecast area. And as I'll talk about, those are significant features in that flash flooding can occur on them pretty quickly. Our most relevant burn scars currently are the Hayden burn scar here up on the Sangres there. And again, note that these burn scars are on very steep terrain. The Junkins burn scar there on the wet mountains, and the spring burn scar there on the southern Sangres is our most recent scar. And I have the dates highlighted there because these burn scars are going to be most relevant within the first 2-3 years after that fire burned. So another important fact about our forecast area is the radar coverage. Of course, like many offices out west, we have radar challenges due to a sparse radar coverage as well as radar beam blockage from the mountainous terrain. So that makes other data sets such as satellite, lightning, ground truth even more important for us. You can see our far southeast plains has a radar hole. Our closest beams are shooting well over 10,000 feet above ground level, which is pretty high into a storm. And also the whole western part of our forecast area, pretty poor radar coverage due to beam blockage. And you could see those 3 newer burn scars. Pretty good coverage from the east, but we'll have storms, of course, moving from the west, northwest, southeast, southwest, where we have very low visuals of the storms heading towards those burn scars. So again, zooming in on the burn scar areas, you could see as you get from into the greens to the blues, that's poorer radar coverage. pretty bad west of the burn scars, again, making it very difficult to see storms moving, approaching those features. So real quickly, what is a burn scar? Our service hydrologist in our office likes to say, basically everything you knew about the land before the fire is completely different after the burn scar, and that's really due to three main changes that affect the hydrology of that area. So as precipit's falling on the area, it's going to act differently than before the fire. Interception is really the longest lasting change to the environment within a burn scar. You're destroying all the leafy material on the trees and on the ground. So usually when rain falls in a forested area, it'll hit the leaves, it'll hit the trees and basically slowly come down the trunk. So it's slow to reach the ground. Once you burn all that off, the rain is going straight to the ground. There's nothing to slow it down. So you're having a rush of water hitting the ground all at the same time. Infiltration is kind of most relevant within the first couple months after the fire. Basically, you're scorching the ground and essentially in those high burn areas turning it to glass. So as the rain hits the ground, it's rushing extremely quickly over that ground again because it's basically running on glass. And finally, in the high burn areas, soil weathering is basically aging your soil, increasing the potential to move that ground, creating high concentration flows. So what types of hydro problems are we expecting on burn scars? Of course, flash floods, which is basically just the water, liquid water, rushing down the scar. Again, as I mentioned, our scars are on mountainous terrain, so not only are we dealing with the lack of the vegetation and that hydrophobic surface, but we're also dealing with gravity, water rushing down mountains into streams and eventually to towns. You have the hyperconcentrated flows, which is basically a very dense, very destructive flow. And finally, debris flows, which is carrying a lot of sediment and other types of debris, which can be very damaging. So the Pueblo, the problem children, as we like to call them in Pueblo currently, the three burn scars I mentioned, this just gives you an idea of what we're looking for in terms of how much rain is falling on the scars that could produce flash flooding or debris flow. And you can see it's really not a lot. For our most recent scar, that spring fire, all it takes is really about 1/3 of an inch of rain within an hour to cause extreme damaging flash flooding or very high rain rates for a couple of scans. We established these rates based on, initially, it's a low threshold, and based on experience through rain falling on the burn scars, we can kind of adjust them over time. So an important thing for us in forecasting over these burn scars in terms of how much rain is going to cause some damage and some trouble is mapping. Not only do we want to know where the burn scars are, we have excellent maps produced by aircraft of the shape of the scar and exactly where it is, but specifically we want to know which areas of the burn scars have been burned the most because that will impact how prone those areas are to flooding. You guys might be familiar with the BARC maps, burn area reflectance classification maps. Those are made primarily from Landsat imagery and other very high resolution imagery. As you're aware, that's only available every 8 days, and if we have clouds over the area, it'll be useless. Really our long-term most useful maps are the BEAR team assessment maps. The BEAR team is the Burn Area Emergency Response Team. So these are folks after the fire or when the fire is pretty far along, mostly contained. These teams will go on the fire, and their team's made up of hydrologists, geologists, soil experts, biologists. They go on the fire and spend 2 weeks studying the burned areas and the changes that have been made in those areas. And basically they're doing things like calculating values at risk, flood flows, et cetera. And eventually they make a report and provide recommendations. And some of the aspects of the report are maps, including these burn severity maps. So from their studies, they can tell us which areas burn the most. The reds are the high burn areas, oranges are moderate burn and yellows are low burn. And you can see with this fire, you have the streaks of high burn areas surrounded by lower burn areas. But again, these maps aren't available till usually a couple weeks after the fire is done. So, or after the fire is completed. So we want something before that, because oftentimes we'll have precipitation falling on those burn scars before we get those maps, where we're really flying blind. We don't know which areas have burned the most and pose the highest potential for flooding. So that's where the JPSS team comes in. So for example, looking at the spring burn scar as an example from this last year in 2018, this fire, third largest fire in Colorado history, 108,000 acres burned. It started June 27th, and already 2 days later, 38,000 acres burned. And about a week and a half later, 105,000 acres burned. But we didn't get this detailed map with the highest burn areas until July 21st. So about 2.5 weeks after, we already had burned a lot of areas. So that's a long time, a lot of potential for storms to hit the burn scar and cause flooding where we did not have any information about burn intensity, which areas have burned the most. So that's where this JPSS Bridge burn scar mapping tool comes in. Bridge stands for Burn Intensity Delta Greenness Estimate, and it's fairly simple. Basically, it's using VIIRS imagery, the NDVI product, which is an operational JPSS VIIRS product, and it's doing some things and eventually taking the difference between NDVI before the fire, before you burn that area, taking the difference with that landscape after the fire to create a map of the change in the NDVI. And based on that change in greenness, it does give an idea of which areas scorched the most, which areas lost the most vegetation, and might be the most prone to flooding. So just an example of the bridge map for the spring fire, which is that fire I just told you, the very large one, over 105,000 acres. This is an example of a map after the fire, just so you can compare it to the detailed Bear Team maps we have. And you could see this northwest portion burned very hard, correlates well with the final Bear map. You have this streak of high burn in the southwest portion, highlighted, correlating well. High burn in the middle of the fire, then some patchy high burn in the southeast part of the fire. Again, this project is very much in its infancy. This is the only map I have for this, but seeing this, comparing it with the final Bear map, I like what I see. And again, this is a map we can be getting daily during a fire as it's burning, as the fire is progressing, more areas burning, so that we could see, in basically almost in real time every day, which areas we need to watch closely for the potential for flash flooding on that burn scar. So definitely a project I like to see continue, and hopefully see pretty soon some sort of operational product. The current idea was to have a web-based portal where Weather Service folks could easily go on it, request an area to create the map, and then it'll plop it out for them. Again, project in its infancy. Maybe that'll happen. An additional idea might be to get something into AWIPS, but again, our other Bear maps are not in AWIPS, and that's fine. So as long as there's something that we can easily access, generate these maps quickly, that would be really valuable to us. So that's everything I have in this block regarding burn scars and mapping the burn scars so that we know which areas burn the most. I'd certainly like to hear any questions or ideas for this type of aspect of this talk with regards to mapping the burn scars.
So, Bill, we have two questions on Slido. One is, how crucial are gauge deployments in burn areas, and where are those measurements used?
Yeah,
let me just read them both and you can address them. Second is, how long do the burn scars maintain their integrity in the GOES 1617 or VIIRS 0.86 micrometer imagery?
So we rely very heavily on rain gauges deployed around and over the burn areas. Those are usually put out after weeks or maybe even a month or so after the fire is finished burning. So again, while the fire is burning and immediately after, we are flying blind in terms of knowing exactly how much precip is falling aside from radar estimates. But yes, those gauge deployments are extremely important. We always wish we could have more gauges, for sure. And then how long the burn scars maintain their integrity. Go 16, 17 imagery, sure, you could see the burn area, but usually these burn scars, 108,000 acres is big, but it's not huge and not as clear in the GOES imagery as it is in the VIIRS imagery. I'm sure in VIIRS it'll show up as long as the burned area is still lacking vegetation. So after 2-3 years, you'll start to see some green up, but you'll still be able to see the scar. The Waldo Canyon burn scar, which you Colorado folks would probably be familiar with, just west of Colorado Springs, big fire, 2012. But now here, 7 years later, you can't even probably see it in imagery, and we've dumped over 2 inches of rain in an hour on that burn scar, and it took it fine. So once, again, you get beyond 3 years, they're pretty well recovered.
So Bill, one question I had was you showed a table with the rainfall rates, a third of an inch total, half an inch per hour. I think that was for the spring burn scar. How would that compare to what would a rainfall rate without the burn scar in this sort of terrain be to prompt a flash flood warning or a flood advisory?
It'll certainly vary from area to area. Those areas might be per hour, so instead of a third of an inch to half an inch, it would probably be 1.5 inches to 2 inches in those areas, maybe even more. Probably over 2 inches to prompt a flash flood warning over those areas without a burn scar. So it certainly takes a lot more precip. So GPM iMerge. How coarse are those data? So I guess the question comes, no, it could be useful, but what's the latency on those data? How quickly can I see those precipitation rates after the measurements are made? Because these are extremely fluid, fast-moving situations. If the data is over 15 minutes latent, then it's not going to be as useful. Yeah. If it's within a half an hour, maybe we'll get use out of it. But outside of a half an hour, it's just going to be too late. The flooding's already happening.
Did you discuss who was responsible for deploying the gauges? Is it BLM or USGS or just sort of different land management agencies? Is that what it is?
Yeah, it depends, where the fire burned. Might be U.S. Forest Service if it's a lot of their land.
Okay, a quick reminder, you can vote these questions up, and if we don't get to a certain number of questions, we can always address them later. Did you address all of those? About collaborators with the JPSS bridge product. Did you discuss that? I don't know that there are, right?
I know Sam something from SSEC is working on it. I think it's primarily a JPSS tool, but they are collaborating with I forget her name, but Western Region Hydro folks. They are collaborating with those folks. So they are in close communication with fire, weather, burn, scar type experts to help generate that product.
Okay, let's go to the next block.
Can you bring up the slides, please, Matt? So, next slide. All right, I guess I got it. So we're going to first talk about September 2017 case. So recall this is roughly, 5 months after we 4 or 5 months after we started getting GOES-R data into AOWEB. So pretty early on the GOES-R and National Weather Service era. So this was an early case, nighttime case, where we were threatening our highest population area, Colorado Springs, as well as the Junkins burn scar which was a 2016 burn, and within the first year of the burn, so very susceptible to flash flooding. So just a quick synoptic overview I want to do here. You could see a deep, pretty strong early fall trough over the western U.S., and you could see in water vapor imagery spreading some pretty strong forcing out ahead of that trough over Colorado here, and also pulling up a lot of moisture into the state. You could see from the mid-level charts a lot of moisture streaming into Colorado. But again, this is late September. We're pretty cool temperature-wise, modest dew points though, but still very weak instability with this case, so not really expecting strong storms, very weak convection, if any. Pretty good isentropic lift into the state as well, so maybe some non-convective heavy rain, some warm rain processes producing some heavy rain over the state, which is what we're looking at. The NESDIS operational TPW products, we love those, particularly for assessing the flash flood potential or heavy rain potential in our forecast area, specifically the TPW percent of normal. So we get an idea of how anomalous this moisture is over our area. So with this case, you could see over the southeast plains, very anomalous moisture, double what is usual for this time of year, and over the I-25 corridor and mountains, roughly 150% of normal. So once we start seeing over 125, especially over 150% of normal, we're definitely considering heavy rain as a possibility in those areas. SAT radars. So I think my Weather Service colleagues can agree, the radars are getting old, and at least in Pueblo, it seems like every month, every couple months, there's another problem. This last month, we were 100 degrees in our forecast area, and the radar AC units were failing, so it wasn't cooling. So during the heat of the afternoon, we either couldn't use our radar, or we had ETs out there pouring water on something. I don't know what they were doing, but literally, they were out there trying to keep our radar running. In this event, we had a major part of the radar fail, so we were in the midst of a multi-week radar outage. And of course, that day, the Denver radar decided to go down as well. So usually Denver's radar it's a pretty good substitute, especially for our I-25 corridor, northern areas of our forecast area. But in this case, no radar coverage. Lowest beams from Cheyenne and Goodland, of course, very far away, over 20,000 feet above ground level. And especially in this situation, when I mentioned it would probably be maybe a warm rain process induced heavy rain, we're not going to see anything. And you can see that from this radar loop. We don't have any coverage. And at the end of the loop, Denver's radar comes back on, and you can see what we would have seen from that. So an event where we're going to have to rely on something else. And this is a good time to mention satellite lightning, rain gauge, or satellite lightning. It's no substitute for radar in these heavy rain events or in convective monitoring. Radar is always going to be our bread and butter for warning operations. You cannot substitute that with satellite. But there are situations like this where we don't have radar, so we have to do the best with what we have, and that's using a combination of products such as lightning data, satellite data, et cetera. But I don't want people to see these talks and think, oh, you have GOES-R now, you don't need a new radar in this area. That is not true. We want as many radars as we can get. So, of course, no radar coverage. Of course, we requested a meso sector. Again, this is in the early days, so I didn't get too upset, but I was a little upset that our meso request was denied. I'm pretty sure at this time the procedures, the priorities were in place in September, but we requested a sector, of course, we had an SPC marginal risk with both radars down and a burn scar flash flood threat. So I would think that would get us level 5 for DSS, since it was pretty significant. Nowadays, I don't think this would be a problem, but back then it was still early. If you remember this time period, it was when Hurricane Maria was happening. It had just gone through Puerto Rico and took out their radar. So of course it was understood that they would get one mesosector because they didn't have any radar coverage down there, but our sector was denied so that the other sector could go over Hurricane Maria, which wasn't near land. It wasn't impacting anything. There weren't any TC warnings. I think it was more of a matter of watching the pretty storm out at sea when us lowly folks in Pueblo, Colorado, we really could have used that operationally on this day. So it was pretty disappointing. And based on the experience we've already had using that radar or that 1 minute imagery, we definitely think it would have helped us with this event. So we'll be looking at 5 minute data, so you could switch to AWIPS. So we'll look earlier in this event. Starting out, this is a display I like to look at in AWIPS, especially early on in the day. So this first period, late afternoon, monitoring the environment leading up to storm development, et cetera. Again, looking at water vapor imagery through the mid-afternoon, you could see shortwave energy out ahead of that deeper trough streaming over Colorado with plenty of moisture streaming over as well. Not a lot of convection though. You could see maybe some convective elements down in southeast Colorado. I'm always looking at those satellite-derived winds. In this case, you could see pretty strong jet level winds over the area. Those are those centered around 300 millibars, Matt? Mm-hmm. So what I'm looking at usually with the winds, particularly in this kind of case, you have a lot of cloud cover, so generally your winds are going to be in the mid to upper levels because you're blocking the scene from lower down in the atmosphere. Looking for any subtle jet features that might help enhance convective development, maybe in the entrance or exit region of a jet, or maybe those localized area of stronger jet winds might enhance your shear a little bit, providing intensification of storms in those areas or providing a little extra lift. In this case, I'm not seeing necessarily a whole lot of anything that would stand out and tell me that storms are going to be, that the winds are going to enhance things too much. Maybe a localized jet up in this area. You can see stronger winds up here, weaker, slightly weaker down here, but nothing too intense. And looking at the longer IR portion of this loop, again, looks like the main convective elements are to the east. Not a whole lot going on in here, but again, as I mentioned, a lot of moisture, but lacking instability. Now, Pueblo, we are not an upper air site, so we have no radiosonde, we have no sounding data. So any other sorts of sounding information we will always take and take a gander at. We'll look at model soundings, and we'll also look at NewCaps as another tool. So if you're familiar with NewCaps, the green dots have passed QC in both the IR and microwave. Kind of surprising that this one passed given the cloud cover, but let's look at the one over Pueblo County. This is Pueblo, Colorado Springs. Yeah. So you click on that sounding, that dot, and the sounding pops up. And then pretty moist, you could see a pretty moist profile throughout. But lapse rates are not impressive at all. So kind of the profile I would expect to see PW up to 0.9 inches. Maybe it's a little higher given these soundings are a little smoothed out. But this profile not showing any instability. Matt, can you go back to the previous tab to see the surface conditions? So if you're familiar with NewCaps, it sometimes gets the surface, has trouble getting the correct surface conditions. So we'll look at a nearby METAR 62/54 and go back to the NewCaps profile and compare it. So it looks actually like it's pretty close. A little off, so we'll want to modify that. So it's very easy to modify these profiles, and there is a project to automate that modification, which would be great. Basically, the project is going to bring in RTMA data to automate the adjustment of those profiles. But in the meantime, all you have to do is click in the tool Edit Graph, and dots show up, and you just drag the temperature to 62. Just a little more. And then the dew point, that's good to 54. So just a little, the profile was a little cool, a little dry. And when you make those adjustments, you do have a little bit of instability introduced there, but still they're modifying up in the mixed layer a little bit. Still very weak instability, so giving me confidence that, okay, instability is weak in that area, so probably not expecting much convection, and if there is convection, be very weak. But a lot of moisture here, still approaching an inch, which is near or above normal. And again, from the TPW blended product, we were seeing even higher instability. So can you go to tab 2? Yeah. Okay. Yeah, just loop that quick. And again, this is before GLM was available, so we're looking at Earth Networks data here. And as I mentioned, you have the convection out east with some lightning. Actually, there was a lightning flash, a couple lightning in there over Pueblo County, so we are getting some convective elements out here. But you can see relatively warm tops, not deep convection at all, but very weak convection, low topped. Again, no radar coverage, so this is all we're using right now. And finally, go to the last tab. So looking at the day cloud phase distinction RGB, this is up there, one of, if not the favorite RGBs in our office. And really the two standouts, and maybe other weather service people might agree, the day cloud phase distinction RGB and nighttime microphysics RGB are by far our favorites in our office for cloud monitoring. This RGB in particular, the two main uses we have are in winter cases where we have snow cover. Compared to the VIS, we really are able to highlight where we have low clouds over snow cover with this RGB, which we can't do with other imagery or alone, visible imagery alone. But also in convective situations, we're watching the colors change from the blues, which are liquid water clouds, to the greens, which is when you're introducing ice into the clouds, and then eventually to yellows when you're cooling those ice clouds. So at this point, actually you can see, this is before the spring scar, so this wasn't here yet, but Junkins was here, and of course we're always concerned with potential flash flooding over Colorado Springs area, big urban area. And you could see as those clouds are streaming north into Pueblo County, you are introducing, quick development into the greens, which again, you're going from cyan to green, you're losing your blue component, aka your 1.6 micron snow ice band is getting a lower reflectance, so you're losing the ice. Telling us that while we do have a little bit of convection there, we're introducing some ice into the clouds and even some lightning periodically in that case. So I do want to mention during this day there was a search and rescue exercise going on in Colorado Springs, just a practice exercise, but this is the type of event where we are in close communication with those search and rescue folks, providing them with weather information, and of course, if lightning's moving overhead or nearby, we're going to want to let them know that that's occurring, and they're going to want to get inside. Again, this is just a practice exercise, so we definitely don't want to put them at risk. So this is a type of situation where GLM data would be useful to see the extent of that lightning if it was extending out towards that area. But at this point, we would put those folks on alert based on that information. We see the ice developing in the clouds, and we see some lightning activity. We want to tell them there might be some storms moving up from the south at this time, and they'll want to be ready maybe to get out of there. So at this time, we can move ahead to the next time period. Let's go to 0030 UTC. And I think this is the only perspective that we need to load for this case, Matt. So now we'll move ahead a little bit in time. So we'll just, you could start with this. That was fast. Okay, so now we're after dark, so this product is becoming not useful anymore. I will mention as the sun's setting or early in the morning, I will adjust, and maybe some of the other weather folks do this. Are you adjusting the ranges of the day cloud phase distinction to make it a little more useful towards sunset or towards sunrise? Maybe we could do that quick just to show folks what it's like for us to do that. So right-click hold on the RGB, composite options. And then it's really simple. You can see these are the ranges for the 3 components for the RGB, and we could do this with any RGB. And essentially, so we're getting darker, so our range for the green is going to be lower, so I drag the green bar down. So again, you're able to use that product a little later, and probably drag blue down a little bit as well. So this is getting a little too late, but we've extended the usefulness at least maybe up to a half an hour for this product. So I think something that, forecasters, should get comfortable doing. It's very easy to do. And again, with some of the RGBs, it's extending their usefulness a little later in the day and a little earlier in the day as the sun angle goes down. Your reflectance in those visible bands or near IR bands is going down. So now you could switch to the IR, I think the second tab. So at this point, we mentioned that those clouds, maybe some convective elements streaming through Pueblo County. So we'll loop 24 frames, so 2 hours. As those clouds, those cooling clouds move through Pueblo County with a little bit of lightning, we were receiving reports of those clouds right there, a little early on, right at that point. Reports of heavy rainfall in Pueblo West, which is just west of Pueblo, with cooling clouds, not excessively cool, but some convective elements. You could see some in-cloud flashes with those clouds, and again, the heavy rain occurring in this area. Of course, those clouds moving up towards Colorado Springs. So about midway through this, well, early on in this loop, around 0Z, again, we called the search and rescue folks and let them know that there were some convective clouds and potentially heavy rain moving towards that area, given that heavy rain was occurring in Pueblo West under that temperature, but as those clouds moved north, they cooled significantly approaching Colorado Springs. So would expect, given that, probably heavy rain going to occur in Colorado Springs too. Again, no radar coverage, so we're just thinking heavy rain with that in Pueblo West, definitely got to be heavy rain up in Colorado Springs, especially as those clouds are cooling and perhaps developing slightly more convective elements with some more localized areas of cooler cloud tops and even more lightning. So we called the search and rescue team and told them to cancel their operation as the lightning approached the area. And we also issued a aerial urban flood advisory, urban and small stream flood advisory for most of Colorado Springs. Colorado Springs, easy to flood. Of course, it's an urban area. So that advisory decision based solely off of the fact that those clouds were producing heavy rain here and were continued to cool as they approached Colorado Springs. And shortly thereafter, we did receive reports of minor street flooding. There was actually one water rescue necessary with this event, but we had that alert out pretty quick. We got those folks out of the middle of Colorado Springs in time so nothing bad happened. Now we turn our attention further south. You can see this area of, again, cooling clouds. I think there might have been, a couple lightning cloud flashes occurring in that area. And so we start watching that because it is starting to approach this burn scar. This is, again, the Junkins burn scar. And given the fact that we had heavy rain generated from this area, we're concerned that this little blob of moisture coming up might produce heavy rain as well. So we can move to the next time, 0150 UTC, looking at the same loop. This is pretty much all we have for this event. We're looking at IR. I don't think we ever even got rain gauges on the Junkins burn scar, just a matter of where it burned. There was no one to support rain gauges, so we rely on storm spotters in the area to get heavy rain reports. And again, this is late at night, so, well, not too late, but we try not to call people too late in the evening unless it's extremely life-threatening. So you could see through this period, the clouds continue to cool and move up towards the Junkins. So we're extremely concerned about the burn scars, but we don't want to issue a flash flood warning for every single event. We don't want to kind of dilute that. So we really only want to save the warnings for when we know flash flooding is occurring or going to occur. But we're still very concerned. We don't really know what's happening. So by the end of this loop, given what's happening here, we issued a flood advisory for the burn scar. And one of the reasons we're fairly confident that it wasn't going to be too bad is we are accounting for parallax. So in southern Colorado, generally the cloud tops would be, due to parallax, shifted. Usually, depending on the cloud top height, 5 to 10 kilometers shifted to the northwest. So if you think, the rain, what would be falling from these clouds would primarily be probably to the southeast of the burn scar. So in the Weather Service, I think we've gotten pretty used to where you're forecasting that degree of parallax, and I hope forecasters are accounting for it if they're having to use it in these types of situations. So given that, we didn't expect, probably if it is falling on the burn scar, maybe right on the edge, but it's probably further to the east. But again, to be safe, we just went with the flood advisory. And what happened, we received reports of light to moderate rain just off the burn scar. We didn't really receive any reports of any flooding on the burn scar. So pretty much as expected. It was good we issued the product just in case, but again, no radar data. So we were working with what we had, but I thought it was great that the forecaster working this event noted, what happened earlier in this area, and then she saw the cooling cloud tops moving towards the burn scar, and went with a product solely based on the satellite data. I think that's all I want to talk about for this case. I'd be welcome to a discussion now if there are any questions, comments.
Yeah, there are a couple of questions, Bill. One, roughly how much lead time do you aim for with flash flood warnings to provide sufficient notice for emergency responders to mitigate impacts near urban interface burn scars?
So we've recently, what we do now, again, we don't want to issue a flash flood warning if it's not going to flood, because we really want our community to take those seriously. We are always in close contact with the local emergency managers and whatever recovery teams might be on the fires. This is another thing that's constantly ongoing. There are people on those burn scars helping to mitigate flooding and helping repair the burn scar, basically. So we're in constant communication with those folks too. So if we see something like this, and I should have mentioned it, before we would even issue a product, we have a cell phone in the office. We have text groups. We would text the folks relevant to that burn scar. Maybe it's emergency managers, the recovery team, maybe some fire department folks, sheriff's department. We would text them and tell them, heads up, there might be some moderate to heavy rain approaching the burn scar. Keep an eye out. We might be issuing a product soon, so that those folks are aware. But again, we're not going to issue that warning until we know that heavy rain's falling on the burn scar. And usually the folks that would be most affected are downstream of the burn scar and of the flooding that would occur due to the heavy rain on the burn scar. So we see heavy rain occurring on a burn scar, we can issue the flash flood warning, and the folks that would be impacting still might have at least 15 minutes, half hour, even an hour of lead time, just because it takes time for the water to run down.
So, related question, do you rely on fire partners or relevant emergency managers to get your warnings that you issue via AWIPS, or do you communicate in other ways with it?
Yeah, and again, that's a change we most recently put in. Usually those partners will know that we're going to issue a warning before we issue it, so we have separate interactions with them. But of course, we're not interacting with everyone, so there might be some of those partners that don't get it until we issue it. But for the most part, the most relevant folks for that area are knowing that we're going to probably issue something or might issue something ahead of time.
Question?
Sure. So the relative greater difference for NDVI, have you thought about how this compares to something like pre and post frost vegetation killing? No, but that could be another use if your ag partners or whoever is interested in whether you had a widespread kill from a frost or freeze. I would think this would be able to capture that, so that might be another potential use. That's a really good idea. And as for the Nestis TPW products, those are a blend of products. Maybe someone else can speak. Is there someone in the room that has more information about those? But it's a blend of a polar satellite data. I think there's some GOES data put into that. And that is an operational product generated operationally at Nestis. So yes, it does include those data sets among others. GPS, occultation, whatever data. Tough word.
Okay, so I think you addressed the without radar coverage, you sort of manually eyeballed, estimated the parallax error to try and estimate where the weather was occurring. You got a vote of some day cloud phase and nighttime microphysics being favored RGBs. I think you sort of addressed the lower visibility product like a flood advisory that you do communicate with those partners.
Yep.
So why don't we save some time? You have 2 more blocks, and we can move on to the next one then.
Bill?
Yeah, just a couple slides. No, we're not looking at land surface temperature for this case at least. So the next case,
Hey, Bill? Can we do one more question on that previous case before you move
sure,
on?
real quick.
So, I watched that Waldo Canyon scar, and you guys had some pretty significant flooding down a major highway there. I think it was Highway 24, and it was occurring. It seemed like you should have had really not a whole lot of consternation over whether or not to issue something as soon as you had any reasonable degree of confidence that a storm was going to pass over that, because it seemed so sensitive that anytime any rain fell on it, you had some sort of flooding that was occurring. And so it seemed like, the need for specific rain gauge reports near the fire wasn't so high in that case. How much decision-making was really being bartered with at that critical moment when you knew a storm was about to pass over it? I mean, didn't it become that sort of thing, like almost a no-brainer as the storm was approaching? Hey, this is going to produce a significant impact.
Especially early on in the first few months to a year, it is a no-brainer, and that's why the thresholds are so low. But after a year, or especially Junkins is a good example. That was late 2016. Now here we are, 2019. We hit it with an inch the other day, and it held fine. So we want to know from those rain gauges how much rain is falling and how much is it taking, and then correlate that to our radar rain rates. But yeah, no, in the first year it's obvious and easy to issue, but after that it gets a little more difficult because it's improving.
Good, yeah, thank you.
So now, again, recall the Hayden fire was in the summer of 2016. So this event is from September 2018, so a little over 2 years after, but this burn scar still susceptible to flooding during this period. Another look at the synoptic setup, pretty similar to the last one, early September, a storm system, the trough not as strong, but spreading forcing, as you can see in the water vapor imagery. You see the short wave here moving across eastern Utah into western Colorado with maybe some lead energy across central Colorado, helping to initiate some storms here by late morning, early afternoon. Also, plenty of moisture streaming up ahead of this trough into south central, southeast Colorado. And again, you can see from the blended TPW product, we're running well above normal for this time of year in this location for TPW. So we are concerned in this event with flash flooding. But again, similarly to the last case, early fall, it's pretty cool. Lapse rates aren't totally impressive with this fairly weak trough. So pretty weak instability, at least from guidance such as the SPC mesoanalysis and model data. Again, no upper air, so we're going off what we got. So go to the next slide. Oh, sorry, keep forgetting. Oh no, another sad radar. And a sad AWIPS. That's no surprise, right, Weather Service folks? AWIPS is always having issues. So in this event, our Pueblo radar was again down, some transmitter error, nothing new. So we're relying on, fortunately, Denver's radar did not go down this day. Over the area we'll be looking at, Hayden Pass burn scar over 10,000 feet above ground level. So not ideal, but it's good enough and enough to make warning decisions. Again, that radar would be looking at these burn scars from the east, so it has a fairly clear view. However, there are some mountains along the Rampart Range, including Pikes Peak, that would provide beam blockage looking at that burn scar in this situation. Also, AWIPS issues. AWIPS is something you're always wrestling with. For this event, our main issues were our MRMS data were kind of in and out, and even the data we were getting from the Denver radar was kind of having issues. It would periodically be old. So keep that in mind during this event. The data is all there in real time for this, but at times during this event, our radar data from Denver was old or not available, in and out, low res, etc. So similar setup the day before. I'm going to be talking about September 6th, but looking at this from September 5th, way down south central Colorado on the Raton Mesa here, shooting 25,000 feet above ground level. On this day, we had pretty strong storm, some weak instability developed down in this area. You could see in IR data, now similarly cold tops, not really significant cooling throughout the evolution of that storm, but you did see with the GLM data a pretty significant lightning jump as that storm moved south-southeast. So if you're not familiar, the significant weather advisory is a product available to us Weather Service folks to issue in those storms that aren't severe. We don't expect them to become severe, but they might have small hail, less than an inch in diameter, and winds less than 60 miles per hour. So we still want to alert our partners to the fact that this is a strong storm. So given the environment, we didn't expect severe, but we could have some strong storms. So based solely on that lightning jump, the forecaster issued a SIG weather advisory. A lot of this area is in the middle of nowhere, Colorado, so we don't have any verification, but just a neat example to show that when we didn't have radar data, our radar was down, we would rely on ground truth, no ground truth, so we'd issue an SPS based on satellite and lightning data. So next, I think we're ready to go into AWIPS. So just looking at this first time period through 21Z, so through mid-afternoon for this block, and then we'll take a break for some questions. But again, early on in the day, I've got my nice 2-panel water vapor imagery with dry motion winds overlaid with IR on the bottom, and then I'm also monitoring cloud evolution and lightning data on the right here. So looking at first water vapor imagery, again, you see the short wave continuing to progress east with some energy out here across central Colorado, helping to force the initiation of some storms. And what was neat in this case is the forecaster noting some stronger winds a localized jet here in central Colorado. You can see flags plus maybe 55 knots. This is in the around 300 millibars. Slightly weaker to the south by 10 to 15 knots. So what we have here is a very localized jet out ahead of this trough. Probably obviously not picked up in the upper air charts. I'm not sure if model data had picked that up or not, but these are observed winds, so telling us that we do have a localized jet. Maybe that might enhance forcing over central Colorado, which would help storm coverage, and given a lack of instability might help storms last a little longer if they do develop, given the fact that we do have that localized jet. So again, that's where we're looking at in the winds, those maybe isolated upper level jet features, things that might enhance lift, might enhance your deep layer shear a little bit too, to help those storms last a little longer at least. So we could loop the day cloud phase distinction RGB. So again, what we're looking for is a general evolution of the clouds in this region. And what you're seeing is, again, the clouds turning, especially up here, cyan to green as they ice, to yellow as they glaciate and start to cool, which eventually leads to lightning. And that's the general trend you'll see, is that in the distinction RGB, you'll see that change to green to yellow, and eventually the lightning flash as you're introducing ice into that cloud. So during this event, Hayden Pass burn scar, we've got recovery crews on it. Again, improving the land over the burn scar. So we're in constant communication with them via phone call and text, letting them know, when things might start getting dicey in terms of lightning and heavy rain. So at this time, we alerted the local fire chief. Him and his wife are great about getting on that burn scar and telling us what's happening if there's flash flooding occurring after a heavy rain event. And also folks with the recovery team, we're telling them we see the potential for lightning is increasing over the burn area, and they should be on alert and start getting off the burn scar, because we are seeing lightning extending very near the scar, and if you account for parallax, that area near the end of the loop is likely a lightning flash over the burn scar. Do you have, okay. Can you load the Earth Networks CGs on that first one? Yeah. So when we're looking at lightning data, at least in my office, I like to have the GLM up, but also then with CG data, usually NLDN CG data, but we don't have that available for this case. But again, the general trend you'd see is you start to see those clouds glaciate, then you get an in-cloud flash, or a flash, you don't know if it's in or cloud to ground from GLM, and then you'd watch for the CGs from the ground-based networks. So the CGs are going to be the minus signs, and up here in clouds, and there was a CG there with that flash. So the threat's starting to increase for lightning over the burn scars. So again, we contacted those folks based on those cloud trends and lightning trends that they should start getting off the burn scar, based solely on the fact that lightning's occurring in the area. At this point, we're not sure if there's going to be a storm moving over the burn scar, so it's solely a lightning threat, and there you see that flash accounting for parallax over the burn scar. And it looks like Earth Networks didn't pick up. Can you go back one frame? Looks like it didn't even pick up that flash, so GLM, oh, there it is. There's a CG right there. So it did. And then, is that the new caps tab? We could see if new caps is showing us anything useful. Maybe try going forward or back a couple. So new calves passes over or obviously over early afternoon, anywhere over the CONUS, so around the previous frame there, 19Z. So a lot of profiles passing QC. There are some clouds under some of these, so they might still be a little suspect, but how about that one? Yeah. So 68 over 45 there in Salida. Again, these profiles are looking at a larger field of view. See, yeah, there's some clouds, and even though it passed QC, it still looks a little funky there in the low levels. But I could tell you there's definitely not over 2,000 joules of CAPE on that day. What did I say, 60? So looking at that, I think that's definitely a bad profile. Go back. You could exit this. Yeah, there was some low. Try this one. Yeah. So closer to 52 over 36 in Monarch Pass. That looks a little better, but showing 17 joules of CAPE, but much too warm in that profile. So again, we'll edit the graph down to what, 52 over, what was that dew point? Thank you. Once you get the hang of this, it's pretty quick. 36. So more of what I'd expect, weaker instability. Is this showing me something I didn't already know? Probably not. But it's just re-establishing the fact that there isn't much instability. Lapse rates aren't particularly strong, and actually fairly dry in the upper levels, but better moisture in the low to mid levels. I think PW is a little weak on this, as the Nestis blended product showed. We're well above normal for TPW, so I would have assumed the Nestis product was right over this. But again, very weak instability, so maybe some strong storms, but definitely not expecting severe. Heavy rainmakers, the most probable. Oh, this is a good time to do a quick little poll. Who prefers this water vapor color table? I don't want to start any fights, but so the water vapor dry yellow, maybe you could zoom out on that, Matt, so they could see it a little better. So raise your hand if you prefer that color table for water vapor. Who prefers the what is it, the Romby one? Who prefers something else? Okay, so the majority does like this one. That's my favorite. I'm always curious to see what people say about that. All right, I think at this point we could stop. Again, at this point we've alerted the folks on the fire that there's a lightning threat. We're not seeing any signs of heavy rain yet, but they should start, those recovery teams on the burn scar, I should say, should get off the fire because the lightning threat is increasing. So at this point we could take some questions. Oh yeah. At this point, yeah.
So your comment about AWIPS going down prompted a question for those who are not in National Weather Service. How often does AWIPS go down?
It's not necessarily going down, it's just weird things happen like that. I mean, daily, there's an issue. I have to restart at least one of my caves every shift. There are some power users who really push AWIPS to the limits, and I like to do that. So yeah, I'm having to restart a cave every shift because it's getting slow. Stuff starts to not load. I'm sure my weather service colleagues could agree. I know weird stuff happens. Tools might not work. It might just crash or freeze up. Yeah, very often. So it's something we're constantly dealing with.
But normally, for a matter of a few minutes, not like the entire shift, you don't have data to look at to perform your...
Yeah, you're still able to look at stuff. It's just minor, things that, are a little, once one little thing goes wrong, you don't want it to go wrong, and it could go wrong at the wrong time. So,
Right.
yeah, it's not a constant thing, but at some point, usually later in the shift, things are going to start to get clogged up.
So a second question came up about your mention of parallax and whether you have ideas about an AWIPS tool being useful. I mean, since parallax is a function of latitude, longitude, and altitude of the cloud element, I assume you would not necessarily be in favor of some
Yeah.
automated solution, but
A
if you
few
wanna
years
speak to that.
back in the hazardous weather test bed, we looked at parallax corrected imagery, and I mean, maybe you could have a more advanced algorithm, but basically it was shifting from a set height. Of course, the parallax, changes with cloud height. The parallax error is going to be greatest at the top of this tall cloud versus medium or smaller cloud. So you'd have to kind of adjust through that level progressively, and just to do a set parallax correction at a set height is kind of a cheap way to do it. And so, which is why I don't think there was a good way to do it, and I think you just leave the imagery how it is. I like that the GLM data is on the same grid as the ABI data. It has the same parallax error, and I think, at least in my office, forecasters know, the degree of parallax and do adjust for that mentally.
Okay, the next question is whether there's a preferred way, I assume for you, to display GLM over other ABI, superimposed on other ABI or RGB imagery, so that you can still see the details of the ABI.
Yeah, during the day and in the next perspective, you'll see that, but and I'll talk about this later, but I like to have a Viz and IR2 panel when I'm just doing regular convective monitoring, because I do want to see the cloud tops in the raw imagery, the visible and the infrared. So GLM, I find it helpful I've just been overlaying in a separate panel GLM on the day cloud phase distinction RGB during the day, because I don't really care about the convective cloud tops in the day cloud phase distinction RGB. What I'm getting from the RGB again is the low cloud evolution into convective elements. And again, I have a separate 2-panel with my Viz and IR. So yeah, I've messed with it a lot. What's the best way? And for me, this is what I do, and I'm sure every forecaster is different.
Yeah, and just for those who don't know, it is fairly easy to set the alpha and create transparency, or just turn it on
Yeah.
and off, flicker it on
And
and off.
I've tried with doing that semi-transparent on visible imagery, adjusting the alpha for the GLM, but it's still too difficult to see important cloud top features in the visible. I don't want to miss anything.
So this next question is essentially the same. So going to the second one down, do you look at the hourly HER lightning forecast, and if so, is it useful in complex terrain?
Yeah, I'll look at it. The problem out here is it's really a crapshoot where convection's going to go, especially during the monsoon season or this type of events. We know storms are going to develop over the mountains, but exactly where, I don't know. So the HER lightning will show, storms developing and producing lightning, but no way am I going to believe that that's exactly where lightning is going to be. But the usefulness would be timing. Okay, I could expect storms to start producing lightning around this time, and that's what I would be getting from the HER lightning product. So the general trend in lightning overall across the area.
Okay, and finally, this case is from 2017. In 2019, do you think the Pueblo forecasters are more confident in how often do these types of events occur to allow them to gain familiarity?
Yeah, the last case was 2017. This was 2018. Definitely over time we're progressing and becoming more confident. I think obviously I'm a huge satellite geek in an office, so maybe my office had satellite pushed down their throats a lot more than other offices. So, but yes, over time with the experience, certainly 2019 a lot more comfortable. The RGBs were new. Forecasters never used RGBs before GOES-R. Those took maybe a little longer, but once they saw me using them and showing them events where they were helpful and showing stuff that other products that other products cannot show, brand new stuff, it's useful to them, they're going to use it. So those two RGBs, day cloud phase distinction and nighttime microphysics, they use all the time because they saw that they were useful. So, they could take all the training they want, but until they use it and see that it's useful, that's what it takes for them to really have trust in it and use it daily.
Okay. So Bob Ballard prefers the RAM-B water vapor color table. And the last question is really about the higher winds are easily seen. Is there a way to draw isopleths? And there is a tool called PGen in AWIPS.
But, you could
Go
do it manually, and that's something that I would, get into. I think Bob Rabin back in the day was generating, wind analyses using satellite-derived motion winds, and I think that's something that I would like to see if you could automate the process of generating isopleths with those winds. I think that would certainly be a helpful project to pursue for someone.
Okay. Let's go on to block 4.
So now we're just advancing in time for this case. We could go to 2215, already there. So again, this is the display I usually like to use during my convective warning operations. You've got your 2-panel viz and IR with just some point lightning data there. Again, nothing else overlaid, so I can see the cloud tops clearly, see the trends in the cumulus clouds and in the cloud tops, the development of cloud top features. In the middle, radar, again, most important for our warning operations is our radar data. So that I have that big in the middle, and this is where I'll issue my warnings. Then on the right, it might depend on the situation. Usually, again, I'll have my GLM data. No transparency. Again, I want to clearly see the GLM data and the trends. And then down here, depending on the situation, if it's a flash flood heavy rain event, I'll be looking at rain rates or some sort of radar-derived rain rates. Other times it might be MRMS products like mesh, etc. So it varies from case to case, but in general, this is my setup. Then I have another cave over here that has my dual pole 4-panel radar data, so a lot of radar analysis going on over here, as well as I usually probably want to be looking at model data anymore at this point, but there might be some model data over here as well. But general environmental analysis with satellite data is all occurring in here. So at this time, this is through 2215. What are we looking at? So you could see Junkins burn scar looking, pretty decent. There's some convection developing to the northwest, but you could, see in the viz and the IR as that's developing, it's kind of weakening and not really growing upscale too much, streaming off to the northeast. We're not too concerned with that. The spring scar was here at this point, but looking pretty clear, not really any convection around it, just some high clouds. But looking up here at Hayden Pass, and still remember account for parallax, you do see some rapid convective initiation going on just northwest of the burn scar, so probably right on the edge of the burn scar. And if we zoom in on our radar imagery, again, we're also looking at this, and just loop it. You could see we do have some beam blockage in this area northwest of the burn scar, but once you get down here, you have a pretty straight view up to the Denver radar. So early in the loop, we see the convection initiating, a little beam blockage here so you can't see it as well, but the fact that we see a healthy storm developing in satellite imagery, some fairly rapid cooling occurring, as well as you could start looping that GLM data as well. You'll see some increase in lightning activity with that storm as well. So early in this period, we're communicating again, sending an alert to our folks around the fire. Hopefully they're getting off, but at this point we're talking to the fire chief down there saying we do have a storm developing just probably to the northwest of the burn scar based on satellite and lightning data. It's increasing pretty rapidly, And when we're sending that alert, it's still to the northwest, so we're saying, we can't see much on radar yet, but we expect something to be moving towards the burn scar. So again, an alert to our partner that something might be happening on the burn scar pretty soon. And then towards the end of the loop, you do see clearly as we move out of the beam blocked area, the storm developing, quickly on that scar, and seeing, the red in the half-degree scan over the burn scar. It's of course very scary. So issued a flash flood warning. Again, the warning would have been issued based on the radar data, but the trends leading up to it tell us that something's probably imminent, and allowed us to get an early alert to our partners on the fire that will something might be happening pretty soon. And you could see the rain rates pretty heavy. This is instantaneous rain rate, 1 to 2 inches per hour rain rate at that time. And if you click off the instantaneous, so up to this point, we've only had, around 1/10, maybe 2/10 of an inch. So when we issued that, it wasn't even to criteria yet. But I think around this event, like a week or two before, we had some significant flash flooding and debris flow on the scar. So we were very concerned that it wouldn't take much to flood that bad boy again. And you could see in AWIPS we have our thresholds. If you see a ½ inch over an hour period or 3/4 of an inch instantaneous rainfall rates, we're going to issue a warning, and that's what we're starting to see here. So at this point, we have the warning out. We've sent notifications. We can move on to the next time step, 22:45 UTC. So at this point, the warning's out. Usually I issue these burn scar flash flood warnings for roughly 3 hours. If you need to end it early, that's fine, but again, it takes time for the water to move off the burn scar and cause issues downstream. So you could see in the Viz and IR data, basically continued cooling of the tops with that storm as it's moving over the burn scar. And you could get an idea of the parallax in the satellite imagery. And given the angle, you could see basically the bottom and side of the cloud, so you can basically see that it is moving over the burn scar. But what we're getting from the satellite imagery at this point is that is a healthy convective development still occurring, very active storm top with all of the texture. It's not a severe storm. There's not an overshooting top or any of those other storm top features, but we're seeing, the texture and the continued cooling. So we know that that storm is healthy. It's still probably going to continue to produce heavy rain, at least in the near future. And you could loop the radar image too. Again, this is going back, but also continuing through. You could see the main storm. It's moving. We've got some decent flow. During monsoon season, oftentimes these storms don't move at all. So at least during this type of event, the storms are moving off the burn scar. But again, the damage has already been done. Is this on the can you move this one to the last frame? So by the end of this period, you could see we have probably over a ½ inch had fallen, so that reached criteria. And again, during this whole period, we're still alerting our partner. You can loop the GLM as well. We're telling them that first storm it's on the southeast end of the burn scar. It's moving off. It's still strong and still going to be producing heavy rain on that southeast edge. But at the same time now, we're continuing to look to the northwest of that activity, and you start to see some new convective development up in southern Chaffee County here, cooling and an active storm top. Looking back at the GLM, you see that first storm still has a decent lightning activity. Is this the 1 minute GLM? Or is it the 5 minute accumulation? Can you just do a right click? Okay. Okay. So I will, for these events, can you right-click again and right-click hold on the FED? I think yeah, that top one. Yeah. So I will just adjust the color table down to, because, I mean, they're not extremely active with lightning. We're not going to get that many flashes. So I'll take it down just so I could see, relevant features and trends a little better in the lightning data. Yeah, take it down to like 100, because we're not going to get, that much lightning. Again, fairly weak instability. It's not going to be too active lightning-wise. So you could see with that first storm, you were fairly active in lightning activity for quite a time, and it does start to downtick. But again, it's moving off the burn scar. We could see that in radar data. We do see to the northwest that storm start to develop some lightning as well. So that might be strengthening. You could see it in the VIS and IR. And again, not much in radar because we do have some beam blockage from some terrain up here. So at this time, we're continuing the flash flood warning because it's pretty active on that scar. We're still telling our partner there's lightning over the area. Don't go out and look for flash flooding yet. It could be dangerous. And we are also telling our partners down there that it might not be over yet. There might be some new activity developing to the northwest based on satellite and lightning data. So we can move ahead to the next time step, 2335. And at this point, we're seeing that initial storm move off the burn scar. Which is a good thing, but of course, we may not be out of the woods yet. All right. So now you do start to see then, as that second storm moves into a clear beam, you could start to see the higher reflectivity on it. Now, as we're watching that second storm approach, you're seeing that maybe it's taking a little more of a northerly track compared to the last one, and we knew the last storm tracked kind of over the northeast edge of the scar. Accounting for parallax, it's going to be close, but thinking that maybe this scar might just skim the northeast part of the burn scar. So again, that's something we're telling our partners. There's another storm approaching. We're thinking it might just miss. And you could see with the lightning activity, So basically at this point, we're continuing the warning due to the fact that we've already had heavy rain on the scar. We have another storm approaching. You continue to see a development and cooling with that second storm, despite the fact that a storm already moved through. We're concerned with that approach. And again, based on the satellite and lightning data with that next storm, we're continuing the warning and telling our partners there on the fire that one more round probably coming, maybe more, but it doesn't look like there's much activity behind it anymore in the origination area of those storms. So now we'll make Matt do it all again and move forward one more time step to 0115. So now this will be going towards a time period where the flash flood warning has already been out for almost 2 hours by the end of this, or over 2 hours by the end of this period. So we want to know, we don't have rain gauges on this burn scar, but we want to know what's happening. But again, it's kind of dangerous with the lightning activity. But I think, yeah, so now you can see at the end of this loop, that second storm is beefing up quite a bit. Lightning activity increases significantly, but you could also see in radar imagery that storm is primarily just missing the burn scar. So as we kind of suspected, based on the track a little further north and east of the previous track, it is missing the burn scar, but still quite a bit of lightning activity in the area and accounting for parallax, being able to see the extent of that lightning. It is, extending out over the burn scar, periodically producing CGs, so it's still a dangerous situation over the scar. But looking back behind those storms, it's looking pretty clear back there. So we're telling the fire chief down there that it looks like, this is going to be the last storm. It's moving to the southeast. Give it 20 minutes, and you can go out and look for a verification. But after that, it looks like it's going to be clear based on our satellite and lightning trends. So, shortly after this, the fire chief went out there and did see significant flash flooding, debris flow occurring from this event on the burn scar. And he was safe by that time. The lightning was out of the area, and no one was hurt in this case. This burn scar is a fairly remote area, so the folks that do live on or around the burn scar, their house has either burned down or flooded at this point, so there's not much left in that area. But that's the conclusion, I think. We can move on to more of a discussion.
Yeah, we have 5 minutes, Bill. First two questions are about what about the GOES-R rain rate algorithm product? How good are they, and how often are they used? And then do you use pop-up SKUTs routinely with new caps?
I wish the GOES-R rain rate was awesome, but it's there, and maybe if someone more familiar with it can chime in, but it's my understanding that it was supposed to be correlated to, cloud top IR temperatures with rain rates observed from JPSS, but I don't know if that's happened yet. It was my understanding that the product wasn't quite finished, or to the extent that it was supposed to be. So it's kind of incomplete. And you look at the rain rates and they're not good. It's not useful at all at this point. And as for pop-up SKUT, that's something I forgot to show, but because I generally knew which new caps I wanted to look at. But yeah, we do use pop-up SKUT when looking at new caps. It's a quick and easy way to look at all of the profiles in the scene. And once you see a profile you want to interrogate a little more closely, you could click on it and see a little more. But yeah, we do definitely use that feature.
Okay, and the next one is, why are the MRMS and Q2 2-minute products not being shown? With two question marks.
So, at least in our area, for rain rates, we find the radar dual pole rain rates and rain accumulation to be more accurate than MRMS over our forecast area. That's just how it is, and so we don't really use MRMS for their rain rates. And again, with this case too, our radar wasn't available, so the MRMS would be a little degraded because it's missing those data. But again, it's what we found useful over time, and the dual pole radar rain rate products are more useful or more accurate than the MRMS. And I don't know what the Q2 2-minute product is.
Yeah, I don't either. How long do you keep burn scar overlays and AWIPs? What are the criteria for removing them?
As you can see, Waldo's still there from 2012, Black Forest from 2012. These actually aren't burn scars. Those are just susceptible flooding areas. We keep them there for a long time just because a couple weeks ago we had, as I mentioned, very heavy rainfall on Waldo. We still, if 2.5 inches are falling. So I did issue a flash flood warning for Waldo burn scar last week, and we did have minor street flooding and some mud flowing off of the burn scar. So here already 7 years later, we want to know. It wasn't significant flooding, but most of our fires are 2012 or recently. I don't know, maybe after 10 years we could start taking them off, but we still kind of want to know where they are to be safe.
Okay, along with burning and post-frost killing, could the NDVI be used to assess crop growth for spring melt, early summer, and runoff events?
Probably.
Okay. You can combine the left panes using the sandwich RGB. Yes, that's true. For fires that still have an IMET deployed, how does, if even the IMET, what happened there? Okay, we lost that question. In Albuquerque, having the burn scar still in AWIPS helps us as a reference, I suppose, to put in warning advisory products for end users even years after.
Yep.
Okay.
So, to address that sandwich one, yeah, the sandwich is great, but still, I want to be able to see every single detail in both the vis and IR, and if you use the sandwich RGB, you can't sample the IR temperature, which I sometimes like to do, and still, the features are going to be as most clear when you look at them separately, so that's why I'd like to look at the two-panel.
Okay, we probably have time for a couple more. One is you keep mentioning you're telling the fire chief. What is your primary mode of communicating with them? Phone calls, text,
Yeah. So
chat?
it used to be phone calls, but we recently, and I think other offices do this, have an office iPhone with text groups. So we have a Hayden Pass Burn Scar text group that the fire chief would be on and other folks. So we just bring up Hayden Pass and text them. So we're texting back and forth with them. Because these areas are fairly remote, phone reception, cell reception is very dicey, so texting is the way to go.
Okay, and let's see. So you keep mentioning, okay, we just did that one. Right now you cannot link cursors and loop frames across panels. Would inter-panel cursor and frame linking be useful?
That's true. If they're not in the same, a two-panel or four-panel won't link across these.
Okay, and then we probably ought to make this the final. So you demonstrated use of new caps to assess vertical temperature dew point profiles. What do you use to estimate hodograph shapes to evaluate potential convective modes hazards?
So model data is one thing. If for the dry motion winds, I'll try to, if you're lucky and have couple winds vertically throughout. Usually once you get debris from convection and upper level cloud cover, you're only going to get upper level winds. But if I get winds in the mid levels around 500 millibars, I also have my surface METARs, and I could do a quick and dirty calculation of shear from the derived motion winds. But often that isn't the case. So it might be that, but usually it's just using model data.